Hey guys, Mr. B here, and today we're going to be doing our first lab. Our lab is going to be on density. It's going to be a two-part lab. So I'm going to walk through this lab and I'm going to provide you with all the data and then you can do the calculations on your assignment. In future, our labs might look like this, where I actually do the experiment for you. I know not as much fun as you doing it yourself, but I provide you the data. Other ones, I might just give you the numbers, and then others, I might just send you to another website where you'll do an activity, okay? Let's go ahead and launch into our first part on density. All right, so let's go ahead and start our first part on density. First of all, safety first, even though I'm just dealing with chemicals, right? Just a little bit of zinc and water, nothing real dangerous. It's good to practice safety measures. So for our first part, we're going to be taking the density of a solid. Now let's remember that density is based on two different measurements. We need to know both the volume and the mass. So to help with that, I've got a few tools. Well, first of all, our balance, easy enough, is going to help us with our mass, but then we also need to know the volume. Now some things can be measured very easily, like the second part of our lab, we're going to measure the volume using a little geometry, but we're going to be using zinc today. And if you notice some of the zinc, it's non-toxic, so don't worry, right? This zinc, it's not very easy to measure the length, width, and height of, so we're going to have to use water displacement, which is why I've got my graduated cylinder here, okay? So first thing we've got to do is we're going to put approximately 30 milliliters in our graduated cylinder here. Now notice I did just say approximately. The exact amount doesn't actually matter, but we actually just need to make sure to write down whatever number we get. So there's a little term that I use in lab all the time, and that is expedience is key. So if you were in the lab and if you were actually doing this, I would say don't waste all your time trying to get this at 30 milliliters exactly. Instead, focus on things that are important. All right. Well, you can sort of see right here, a little trick is to sometimes put your hand behind the graduated cylinder, or maybe a blank piece of paper. Okay, that way you can see the line a little bit better. So here we go. Our line is at about, and I'm trying to get the camera to be as level as possible, I'm going to say that's about 31.1. Okay, it's pretty close to exactly on the line, but I'm going to say it's at 31.1. So we're going to record our volume, 31.1 milliliters with our correct units, and then I want the mass. Okay, but right now I've just got the volume of the water. We're going to be using water displacement. Let's go ahead and let's stick this on our balance to get the mass of our graduated cylinder and the water. So let's wait for it. Okay, here we go. 144.19 grams. Okay, it changed a little bit. But it's staying about 1.9. So there we go. We've got the mass of our cylinder and our water. Now I'm going to get approximately, I don't know, I'll just put a few pieces in. The exact amount of zinc doesn't matter because density is an intensive property. The amount of substance doesn't actually impact the density. So I'm just going to plop a bunch in there. Okay, and I'm going to change my view here. Maybe that'll help. There we go. That's much better. Now we're going to, well, there we go. Now we're going to measure the volume afterwards. So now I'm looking at about 32-ish. Tell you what, I'm going to go ahead, I'm going to add a little bit more of my zinc, okay, just to have extra measurement here. Okay. I want a sizable difference in volume. So remember when measuring graduated cylinders, we're going to be looking at the bottom of the meniscus. So here we go, that's about 33.8. So I'm going to write that down. Don't forget when we're measuring things that we need to use proper sig figs. Because my measurements were increments of ones, I need to estimate one place further. Now all I need to do is take the final mass of all of this stuff. Okay? So let's toss it on our balance. 159.4. Ooh, it's changing a lot here. So I really chose a bad spot in the lab because I'm right underneath the air conditioner, and that has a tendency of messing up my measurements. So we're going to write it down, let's say 4, 7. It's been flipping in between those. Okay? So that was my first trial. I'm going to do the exact same thing and give you a second set of data. That way we can do multiple trials. Because remember, in science, we want repeatability, right? We want it to be verified. We want to make sure that one trial wasn't a fluke. So I'll go ahead and I'll do that trial and I'll provide the data in the chart in the question. Okay? And then be ready for part 2.